Hello, this is Kyle. I'm going to be talking about homework 3. Alright, I'm going to be talking about homework 3 for computational methods. And homework 3 is kind of going over if we have a pretty common chemical engineering problem in which we want to solve for mole fractions. Mole fractions have to be between 0 and 1, and also the sum of them has to equal 1. And since there's these two constraints, when we want to solve for the unknowns, if we have, like an example here, if we have a 5-component mixture, it requires 10 constraints, 10 inequality constraints and an additional constraint. And this can be a pain. So we want to take a look at using a transform variable and solving these two equations for the transform variable, which can be a lot easier to use in calculations. We'll put this back here. And then here we go. Alright, so I wrote down the two equations that were given, and we're just going to manipulate this, and we want to solve for VI in terms of the x's, essentially. So we're going to start with this top equation here. And the first thing we're going to want to do is take the natural log. So if we take the natural log of both sides of that equation, we're left with the natural log of xi is equal to the natural log of the right side. And since it's something over something else, we can do subtraction with our natural log rules. So we have natural log of e to the vi minus natural log of 1 plus the summation e to the vi. This cancels, so we're just left with vi here minus natural log 1 plus summation e to the vi. Alright, and then we can take a look at our second equation, which we have xn equals 1 minus the sum of all other x's. And we can kind of take a look at this and plug our top equation into our second equation here. So if we do that, we have xn equal to 1 minus the summation of e to the vi over 1 plus summation e to the vi. And this is kind of a cool interesting thing here. So we have a summation inside of another summation. So since we have a summation inside, in terms of thinking about this outer summation, the inner summation is essentially a constant. It's going to be the one value since it's being summed each time. So we can actually pull that out of the outer summation. So we can have xn equal to 1 minus, and have 1 over 1 plus summation of e to the vi times the summation of e to the vi. And then if we reorganize this, we can add this whole term to the left side and bring x of n over. We have 1 over 1 plus summation e to the vi times the summation e to the vi equal to 1 minus x of n. And then we'll multiply this onto this side, so 1 plus summation e to the vi, multiply that, so it goes away over there and comes over here. Let's see so you can still see. Yep. Alright, and now if we multiply this right side, we have, so we have 1 minus xn plus the summation e to the vi minus xn times the summation of e to the vi. And that is all equal to our only term left over here, which is summation of e to the vi. And now we can see that we have this term on both sides of our equation, so we can cancel that. And we're left with 1 minus xn. Let's see, 1 minus xn minus xn summation e to the vi. And now we can solve for this term here, summation of e to the vi, because we have a like term here that we can then plug it in for. So if we do that, we'll add it to the left side, which would be xn times summation e to the vi equals 1 minus xn. And then we'll divide this xn over to the left side, but let me go to a new sheet of paper. So I'll rewrite the step I had left off at. xn times the summation e to the vi equals 1 minus xn. So if we divide both sides by xn, divide by xn, we're left with the summation of e to the vi equals 1 minus xn over xn. And this will be nice later, but if we use our rules of fraction with a common denominator, we can say that this is the same thing as 1 over xn minus 1, because it would be 1 over xn minus xn over xn, which is obviously 1. So now we can take this term and we can plug it back in for here. So I'll rewrite that formula. We have the natural log of xi equal to vi minus the natural log of 1 plus the summation of e to the vi, which is this term I have here, so 1 over xn minus 1. And the first thing we can see is that the 1's cancel. The next thing, we have a very simple equation if we want to solve for vi. Vi is just equal to the natural log of xi. And then all we had to do was add this natural log over to the other side, so plus the natural log of 1 over xn. And there we have it. We have an equation now solved for our transformed variable instead of our x's. And thanks for tuning in.